Hi guys, so we're going to be sketching the board plots for this particular transfer function. So first of all, you have to get this equation to be dependent on the frequency response. So this transfer function, it basically relates the input to the output in the S domain. So in order to get this equation to depend on the frequency response, we simply substitute that S equals to J W. But you see, one more thing, the board plot works best when the equation is in this form: 1 plus s over w, where wc is the break frequency. So we're going to get this equation to look like that. On the top side, that is s equals to 0.5. You can bring out 0.5, leaving 1 plus s over 0.5. You can see it's in this form now, and 0.5 is the break frequency. Do the same thing for the second part to become 10. 1 plus s over 10. The third one, s plus 50, that's here, equals to 50. 1 plus s over 50. And you can simply substitute back into the equation. Come g of s equals to 10 times 0.5, or 1 plus s over 0.5, all over s times 10 times 50 times s 1 plus s over 10 plus 1 plus s over 50. And then you can simply just bring out the constant to be 1 over 100 times everything. 1 plus s of 0.5 over 1 plus s over 10 times 1 plus s over 50. This constant will basically just shift the magnitude by vertically by about 2 log, actually 20 log 1 over 100, which is equal to minus 40 decibels. So to just shift the magnitude vertically by minus 40 decibels. Magnitude plot, it doesn't affect any other thing. Now we're substituting that s equals to jw. So at every point we're going to have g of s is equals to 1 over 100. That'll be at the top to become 1 plus jw over 0.5. The bottom will become 1 plus jw over 10. And here will also be 1 plus jw over 50. And oh yeah, sorry, I forgot the s that was out here. So s, and then the s will be here, so it's come gw. Now we simply find the poles and the zeros. So zeros are anything that can make the numerator to be 0, and poles are anything that can make the denominator to be 0. So in this case, this is the numerator, so this is definitely 0. We just want to know the value of that 0, so we equate that to 0 to find what will be the answer. So w, if you solve it out, w will be equals to minus 0.5. It means that if I substitute in the value of minus 0.5 here, as at this point, this entire equation will become 0. So therefore, we have found our first 0 at 0.5. Yes, I know I didn't include the minus because the minus shows direction. We only want magnitude since we are working for the board plot. Let us equate it to 0. So GW equals to 0. It means that WB equals to what? 0. So we found our second thing. Pole is at 0, because if you equate this to the denominator, if you equate it to 0 to make this entire denominator 0. The next one is the next formula: JW over 10 is equals to 0. W will be equals to minus J10. It means that if you substitute the value of minus J10, the entire denominator becomes 0. So pole at 10. And then the last one is JW over 50 equals 0. W equals to minus J50, which means that we have a pole at 50. So now we've gotten our descriptions and also our break frequencies already. You could tell this was the break frequency from this point. Now we have our 4 descriptions that we've gotten from the last position, and we also have our frequencies that we got, which was 0 0.1, 0.5, 10, and 50. These are all frequencies. These are our breakout frequencies, remember. For zeros, zeros have a certain effect on slope. They add plus 20 decibels per decade to a slope, and for poles, they add negative 20 decibels per decade, and for a pole at the origin, it adds minus 20 decibels per decade starting immediately. So we're just going to assign them here. So for a pole at 0, this will contribute a value of minus 20. This will be minus 20, minus 20, minus 20. I'll explain shortly. For this particular one, this one is going to be 0. Now let me explain why. For 0 at 0.5, right? We have the formula 1 plus GW over 0.5. Let's say that we're to substitute the value of W in this case as 0.1, and to become 1 plus 0.1G over 0.5. If you had to take the magnitude of this, it basically be 1 square plus 0.1 over 0.5 square. It's going to give you approximately 1. If you now want to find the amount of decibels that this will amplify the signal by, the amount of decibels that is to contribute to this system, you do 2 log 1 equals to, this will be about 0 decibels. That's why it's 0. If you do it for something like 5, it will become 1 plus g, that'll be 0.5 over, for this one, 0.5 over 0.5 is going to be root 1. It will be, sorry, it will be root 2. And by the way, this is 20 log 1, sorry, not 2. Let's come to 20 log root 2 because of our 3 decibels. This will contribute something to the slope. Now, I'm not going to write 3 decibels there because we're not interested in the magnitude that this contributes to the slope. We're actually just going to make use of this standard formula. It's just easier that way. So for in this case, this is a 0. It's going to contribute plus 20. If you did for 10, it's also plus 20, plus 20, plus 20. And then when we move down to this one is going to be 0. This one is going to be 0. This is a pole, so it's going to contribute minus 20, minus 20. Then for this one, so 0, 0, 0, and this one will be minus 20. Do you know why 0? You can do what I did here again. So this is for our slope. So the total slope that is measured in decibels per decade. Here is just going to be minus 20. Here will be minus 20 plus 20, so it will be 0. Here will be minus 20 plus 20, 0. 0 minus 20, will be minus 20. Minus 20 plus 20 is 0. 0 minus 20, minus 20, minus 20 minus 20, minus 40. That is what you're going to get. Now let's move on to the phase. So for this particular one, the first thing you want to know is that phase transition for this particular systems go from 0.1 break frequency to 10 break frequency. To just simply prove that, go for this equation. You're very familiar with this equation, I'm sure. It's simply phi equals to tan inverse of W over WC. And at break frequency, W is equals to WC. So this becomes tan inverse of 1, which is equal to what? 90 degrees. And at W equals to 10 WC, phi is equals to tan inverse of 10, which is approximately 90 degrees. And at about W equals to the starting point, 0.WC, tan inverse as phi will be equals to tan inverse of 0.1 to be equals to 0 degrees. So the transition is from 0 to 90 degrees. I'm just showing you why this is this. So this is going to create a kind of table. So these are the frequencies for 0.5, 10, and 5 and 50. The first one was 0, but we don't need to write it, to won't make sense here. So the first one will be 0.5 times 0.1, that will be 0.05, and sorry, it stops at 10. And 0.5 times 10, 5. You leave all of them 1, 500, and 500. That is how we go all these values here. And those are, you just go down like this, and then you go down like this. That's how the values are written. Note that a total phase change for a zero, I'm not too sure, but the total phase change for a zero is plus 90 degrees, and for a pole, it is negative 90 degrees. And the half point, that's at that break frequency point, it will be 45 degrees, and here to minus 45 degrees. So for 0 at 0.5, the transition started from what? 0.5 and ended at 5. So 0 is what? 45. So it will be 45, 45, then 0. Why is this 0? Because this is where the transition stops. So it's from 0 to about 90, right? So at 0 it starts, then at 90 it completely settles. So yes, the remaining is 0, 0, 0. Next is for the pole at 10, it's going to be minus 45 because the pole, it started from 1 and ended at 100. So it starts from 1 until we go to 100. 100 is where it stops, so 0 and 0. Next one is a pole at 50. The pole at 50 starts from 5 and ends at 500. So you start from the first 5 that you see there. And it's going to be minus 45. And it's going to be minus 45, minus 45, minus 45. Then at this point it's a rest. So this is just it. You simply add, here's 45, here will be 0, 45, this will be minus 90, minus 90, minus 45, and 0. So now it's not just simply to plot. Now to finally make the plot, let's make the plot for the slope first. It's going to be the slope, right, magnitude, which will be measured in dB, against the frequency, which will be measured in W, rats per seconds. We are plotting using log, so we're going to give values of 10, minus 2, 10, minus 1, 10 raised power 0, which is 1. This is 0.1. So just like values, but represent them like this. It helps you to see the exponential change. This will be 10 raised power 2, and the last one will be 10 raised power 3. So I'm just going to say let this be 0, let this be 20 decibels, this one will be 30, this one will be 40, 50, 60. So for the first part of the table, at 0.1 break frequency, we had a value of total slope of minus 20. So at this point, so around that 0.1 point, which is here, we're going to drop it by 20 decibels. Then at the 0.5 break frequency, we had a total slope of 0, so everything will stay accordingly. So if this is 0.1 and this is 1, then 0.5 is around the center, so let's draw it to be almost around the center. So let's draw from here to around here. Now from that 0.5, it just remained a flat line. Now at the next breakpoint, which was 10, 10 is at this point, so it's going to keep going as a flat line to get to this point. At 10, we have a total slope of minus 20, so it will drop again by 20 points. So that will reach around this minus 40. So these are all negatives. So sorry, 50, value of 50. If this is 100 times 50, so around here. If here is 10 and here is around 50, because 10 is about is 100, sorry, times 50 is at the center, so we'll just trace down negative, sorry about the error, negative 20 decibels. Then at the 50 point, that is here that we are now, actually to be, it won't be 50 sure because these are logarithm values. we're going to have a value of minus 40. So it's going to plunge down even deeper to about negative 40 decibels. Sorry, I didn't draw enough points for it. So let's say negative 70 and negative 80. So then we'll just stop it around here. So that's this kind of how the graph will look. This is just a rough sketch, but I feel like you get the point of how the graph will look like. Now I'm going to be drawing a similar plot for this phase equation. But first we want to find out the pole at the origin, the degree that it contributes for all frequencies. Let me just explain. 45 plus 45 is what? 90. Minus 45 minus 45. One thing you don't want to do is actually to include this particular one in your addition. So this is going to be minus 5 minus 45. That will be minus 90. This particular one minus 45 minus 45. Because this is just tautology. If you add up this 5 and this 5, it's just the same thing. You're just repeating the same thing. It's minus 90, and this will also be, yeah, and that's the last one. So you can see that we can say that the pole at the origin contributes minus 90 at all frequencies. So this will factor into our graph. Our graph is, sorry, frequency against phase, which is in degrees. So we can just start to I want minus 90 here, I put minus 45 here, and I put minus 80 here. Then this will simply just be 10 minus 2. This will be 10 minus 1. This will be 10 raised power 0. This will be 10 raised power 1. This will be 10 raised power 2. This will be 10 raised power 3. Now, the total slope for 0.05, which is somewhere around here, was 45. So remember I told you at the origin all frequencies were is negative was minus 90. So it will be negative 90 to get to this point, which is around 0.05. It went up by just 45, which is it went up by positive 5, but positive 45, sorry. So that's it. Then at 1, so it went up by positive 45 till it reached 1, which is around here. So up to this position, is going to be, this slope is going to be increasing by 45. Next, at that frequency of 1, we see no change, just 0. We see no change till we got to 5, and 5 in this case is at this half position. So at this point it stops. Then at that 5 we see a dip by negative 90. So we're going to dip down by about negative 90. Which in this case will be about 135, negative 135. So let's just stop it around here, which will be around negative 35, and it was from 5 to 100. The frequencies was 5 then 100. So this is the 100 point. So let's take it up to this position. Sorry, my handwriting is not so good, but let's take this as negative 135 like that. Now, after this point, at the 100 point, the total slope was negative 45. So we're going to see a fall again. And that fall, if you do because we're at 135, so 135 plus 45, you're going to be at 180. So it's going to dip down to 180. The next frequency is 500, so around maybe here. So that 180 points, and then at that 500 points, the total slope was 0. So it just keeps going as 0. So this is kind of a rough look of what the graph will look like. Thank you for listening, and please like and subscribe.